In this video, we will be learning about graticules and magnification equations. By the end of the session, you should be able to state the equation for magnification, calculate actual size of an object using the magnification equation, and calculate object size using a graticule when using a microscope. First of all, you need to know the words image, object, resolution, and magnification. So make sure that you know these different definitions by pausing the video now and having a go at writing them out. Once you have finished, you can check your answers on the next slide. Here are the answers. So, an image is the appearance of an object or material when viewed under a microscope. The object is the material that is put under a microscope. A resolution is the minimum distance apart that two objects can be in order for them to appear as separate items. And the magnification is how many times bigger the image is when compared to an object. Magnification can be worked out from the equation of magnification equals image size divided by actual size. You will need to demonstrate that you are able to calculate the magnification of an image or the actual size of an object. To do this, the easiest thing that you need to remember is to always measure in millimeters. Do not measure in centimeters. I will show you on the next slide why this is. Millimeters, meters, and kilometers are all different from each other by a factor of 1,000, whereas centimeters are different from meters by a factor of 100, and therefore it will make it very difficult to convert if you have measured in centimeters. If you use the factors of 1,000, so for example meters, millimeters, micrometers, and nanometers, then it's very simple to convert from one to the other. Just follow this simple sequence. To convert to a smaller unit, so for example from meters to millimeters, multiply by 1,000. To convert to a larger unit, for example from nanometers to micrometers, divide by 1,000. Here is the equation that you should have learned at GCSE. For magnification. Magnification is a measure of how many times bigger an image is than the object. To work out magnification, you would divide the size of the image by the actual size of the object. At GCSE, you will have been expected to rearrange that equation to find out what the image size, the actual size, and the magnification are for different calculations. Here are two questions from GCSE. Using the magnification equation, pause the video and work out what the answers should be. The first answer to the first question is 200 divided by 1,500 equals 0.133 millimeters. This works out your actual size of your nucleus. The reason you do 200 divided by 1,500 is because the image size divided by the magnification equals the actual size, which is what you are trying to work out. You get the answer of 0.133 millimeters, but it asks for your answer in micrometers. Therefore, you must convert it to micrometers. As you are going to a smaller unit, you multiply by 1,000. So your actual size of your nucleus is 133.3 micrometers. For the second question, it asks you about the mitochondria, which measures 100 millimeters on a diagram. The magnification is times 10,000, so you needed to work out its actual size. To do this, you would do the image size, which is 100, divided by the magnification, which is 10,000. This equals 0.01 millimeters. You then needed to convert this to micrometers. As you are converting to a smaller unit, you times by 1,000 to get 10 micrometers. Have a go at completing this table. Remember to check your units for image size and actual size, and remember that you will have to use the magnification equation to do this, and you may need to rearrange that equation. Here is the equation if you need it. So, the answer to the first one, the plant cell, you should have worked this out by doing 4 times 1,000 to convert it into micrometers. So 4,000, and then divide that by the actual size, which is 66.6. 4,000 divided by 66.6 gives you a magnification of times 60. For the kidney cell, you should have done 1.5, which is your actual size, times 1,000 to get the image size. So you would have got 1,500. However, as your image size is in millimeters, you need to divide by 1,000 to get 1.5 millimeters. For the bacteria cell, to work out your actual size, you do your image size, times that by 1,000 to get it into micrometers. So you do 4,000 divided by your magnification, which is 700, and that will give you an actual size of 5.7 micrometers. For bacteria, to work out the magnification, you would again have done 4.5 times 1,000 to make it into micrometers. You would have then divided 4,500 by 6.4 to get a magnification of times 500. And for the last one, for the nerve cell, you would have done 2 times 1,000 to get 2,000, and then you would have done 2,000 divided by your magnification, which is 800, which gives you an actual size of 2.5 micrometers. So as well as being able to use the equation, you have to work out actual size from drawing and photographs. And to do this, you can use the equation actual size equals measured lengths divided by magnification. So therefore, the cell below has been magnified by times 15,000 times. You have measured it as 450 millimeters long. Therefore, you would do 450 millimeters divided by 15,000, which gives you 0.03 millimeters. However, your answer should always be converted to micrometers. So to do this, because you're going to a smaller unit, you times by 1,000 to get 30 micrometers. You will also need to be able to use a scale bar to work out magnification. Often microscopic images will have a photograph or drawing of an object with a scale bar next to it. The scale bar, however, does not show magnification, so you need to be able to work out magnification using the equation of measured length divided by scale bar length. So you've got your magnification, which you have worked out. So you're working out your magnification, you have your measured length, which you've worked out as 30 millimeters, and your scale bar label is 2 micrometers. So you need to convert millimeters into micrometers for this equation to work. So you would times that by 1,000, so it becomes 30,000 divided by 2. And so your length for your scale bar is 30,000, so you've measured the length of that. You've times it by 1,000 to get it to micrometers, and then you divide it by 2 because you know that that scale bar represents 2 micrometers. This gives you times 15,000 magnification. Now, do you think this scale bar was found on a photograph from a light microscope or a photomicrograph from an electron microscope? Have a look at the magnification and have a think at which one you think it was. It must have been a photomicrograph from an electron microscope because the maximum magnification of a light microscope is times 1,500, whereas this is much bigger, it's times 15,000, so it must have come from an electron microscope. When you are looking under a microscope, you need 2 pieces of equipment to work out the size of your object. You need a graticule and you need a stage micrometer. The graticule is in the eyepiece lens, whereas the stage micrometer is generally on the stage with the specimen. In lining up the 2 scales, you can work out the unit of measurement for each point on the stage micrometer scale. So you can see there you have your eyepiece graticule scale at the top with the numbers on, and you have your stage micrometer scale, which does not have any numbers on. You need to use the graticule to calibrate this, which means you need to work out the length of each interval. So you know that your eyepiece graticule scale in this case is in millimeters. So you look between your 1 millimeter line and you can see between 5 and 6 that 2 intervals are equal to 1 millimetre. So therefore, one interval must be equal to 0.5 millimetres. So you've worked out that between each line on your stage micrometer is 0.5 millimetres. So I have my dust mite. How big is the dust mite in the picture? And give your answer in micrometers. The dust mite is equivalent to 6 intervals on your stage micrometer. We know that 2 intervals are equal to 1 millimetre. Now if you do 6 divided by 2 is 3 millimetres long. To get it into micrometers, you do 3 times 1,000, which equals 3,000 micrometers. So, by the end of this video, you should now be able to state the equation of magnification, calculate the actual size using the magnification equation, and calculate object size using a graticule.